Does anyone know when this is supposed to end? Like when the next thing today is? Just timing wise. Okay, we'll definitely do that. I was thinking if I have to squish it to 30 minutes or 45 minutes, or if we have time, like whatever the next thing on the agenda is. 11:30 should be okay. All right, cool. Yeah, usually this takes 45 minutes, so uh, it should be fine. Cool, thanks. I'm waiting for anyone more official than me to like kick this off. I don't know if I'm supposed to do that or if I just start talking. All right, I don't see many more people showing up, and no one whose paycheck says Atlas on it has told me to start, but I'm going to go ahead and start anyway.
As a student tutor, I endorse this.
Yay, okay. We have official endorsement to get started. Okay, cool. So, hey everybody, my name's Luke. I see some familiar faces. Anyone, I gave a talk about cryptography. Anybody who came to that one? Woo! Okay, cool. After that talk, I really wanted to talk about HTTPS, but like most of the time when I get really into a topic, it was clear that that was going to take about 3 or 4 months of research to put together a really good one. So I kind of last minute changed this one, which is one that I've done a few times and it's already nice and polished. So you'll get a better talk, but I promise a talk about HTTPS is also coming, which is much more applicable. So for those who don't know me, I don't know if I have an intro. I don't have an intro in this. So yeah, my name's Luke. I work as a privacy and security engineer for Mozilla. We make the Firefox web browser. I got interested in, great, I'm going to be struggling with something in my throat this whole time. So I got interested in the dark web because the Tor, we'll talk about this, the Tor web browser, which is used to access the dark web, is actually a build of Firefox. And so we work with the Tor project in order to help make their work easier. We do things in Firefox. We collaborate with them a lot. They come to our all hands events, and we talk to the Tor project about what we can do to make their life easier to build the Tor browser based on Firefox. So I had a chance in my role to work with the Tor team a little bit. And like most things, I get really intimidated and nervous about tech that I don't know. So before I started saying really stupid things to the Tor project, I was like, I probably want to go learn a lot more about Tor and the dark web than I know right now. So what you're seeing is basically me teaching myself a lot about this stuff, and I find it helpful to package it like this in order to help other people learn it. So yeah, this is how to run your code on the dark web. I don't have as much script on this, so hopefully I won't babble too much. But when we say how to run your code on the dark web, I kind of changed it into this sort of like that feels really dark. So then I change it like, no, it's happy because there is this element of why you should run your code on the dark web, or at least know how to write your code on the dark web. And we'll get into that. So how to run your code starts with how to write your code for the dark web and why you should. So Tor is a browser. Tor is mostly Firefox. It's a patched version of Firefox with the Onion router. So why is those things? EFF has a really good guide on Tor and HTTPS. These slides will be on Speaker Deck, and I'll send a link out so you don't have to worry about writing down any of these links or anything like that. So in their guide, they talk about sort of the technology that makes up the internet. These things in particular, IP, DNS, and HTTP, have all these sorts of threats. So hackers in the middle between you and a server, ISPs snooping on your activity, governments censoring sites or snooping on activity, corporations scanning web logs for competitors, criminal sites scanning to make sure that law enforcement is not investigating them, and things like that. So that's all possible because of the way the internet is built on these technologies. And so they have sort of this guide that explains how Tor and HTTPS together protect from a lot of that. So in this, we're going to walk through this. Don't try to absorb this right now. We're going to come back to it lots and lots of times and very specifically. So don't worry about it. In this diagram, though, there is a point where it says, I think it says location. What they mean by location in that diagram is your IP address. So IP addresses are frequently scanned and then mapped on a map, so that GeoIP is a whole thing. It's a whole industry, but basically based on somebody's IP address, you can usually find out roughly where they are. So let's go through this diagram very piecemeal, in depth, because we're going to use it a lot. No worries. So up in the top left, we're going to start with, this is you. You're the happy person on a laptop trying to connect to site.com. And so when you do that, you're sending user and password and data and your location or your IP address kind of over the Wi-Fi. Now, anybody who's on the same Wi-Fi as you can potentially see all of that as well, right? So that's what this is showing. Now, outside of the Wi-Fi, you go up to the internet service provider. So here in this building, we have a Wi-Fi router. It's right there. I'm looking at it. And that connects to Cox probably. And they're the people that are at Cox, which could be legal, sysadmins, or if they're cooperating with law enforcement, they can see all of that too. Then the ISPs talk to each other, especially over international boundaries. And so those gateway points typically are accessible to like law enforcement, international law enforcement kind of things. So they can see all of that stuff. Then the internet service provider of the website you're contacting can see all of that stuff. And then finally, the people that operate site.com can see all of that stuff, right? So all along the path, those are sort of all of the entities that we care about when we're talking about what we're trying to protect here. Now, who's of HTTPS? All right, that's the talk that's coming, I promise. But so HTTPS is the padlock that's in your browser when you use it. A lot of the internet is now on HTTPS, which is great. It protects the user, password, and data from all of those intermediaries that we just talked about. So if you're using HTTPS, this is why everybody loves it. It basically hides that part from the person on Wi-Fi. It hides that part from your internet service provider. It hides that part from these intermediaries. It hides that part from their internet service provider. And then at the site, obviously, that's where the HTTPS terminates, and then they can still see everything. But it really only takes care of that first threat that we talked about. So hackers in the middle, right? But then how do we protect that other data, that location and destination, from those intermediaries? So the first go-to solution is usually a VPN. Okay, so VPN, okay, it's great. I have a whole other talk on VPNs, which we could give some other time. But the summary of it is some of them are bad, and the good ones usually cost money. So there's a good TED Talk by Christopher Soahan that your smartphone is a civic rights issue. So he says there's now increasingly a gap between privacy and security of the rich who can afford devices that secure their data by default, and the poor whose devices do very little to protect them by default. So if the good VPNs cost money, what is another way that we can protect this location and destination from intermediaries that works for everybody and is free? That's why we have Tor is patched Firefox with the Onion router. So what is the Onion router? So the way that the Onion router works is that if you are Alice and Bob are the eponymous, evergreen heroes of every cryptography story in the world. So Alice is on a computer and she wants to connect to a site that is, let's say it's just a site.com, and she wants to use Tor to do it, the Tor web browser, so that she can remain anonymous. So Alice's Tor client gets a list of all of the Tor nodes that are out there in the world from directory servers. And there's about 12 to 15. One of the guys that's at Mozilla runs one of the ones, like it's just kind of a cool network of people that just run these directory servers. So what that list, when you go look up one of these Tor nodes, like if I've run one before, not all the time, but I just call it Groove Tor, and it has my IP address, the ports to connect, and it has my public key. Okay, and we'll get to the keys in a second. But this is what Alice's Tor client will find if she goes to these directory servers. So she picks 3 out of that list, and she builds a random path to the destination server that Bob is running, like at site.com, right? So we're gonna send this traffic through 3 different servers over the Tor network. We'll get more into the details in a second. But if we go back to this diagram now, when we're using Tor, then what happens is that the Wi-Fi in the middle doesn't get to see, so they will see Alice's device's IP address, where Alice is, but if they're on the same Wi-Fi, they're probably at the same place. However, what they won't see is where Alice is going. So they've lost that. Same with the internet service provider now does not see where Alice is going. Same with the intermediaries. There's these 3 new intermediaries, the 3 Tor relays. And the first one does not see where Alice is going, but Alice is connecting directly to this one, so it can see where she's coming from. The middle one sees nothing, and this is the key link that breaks the location and destination. So no one person ever sees both. The last one doesn't see the location, but sees the other data on the way out. So now the rest of it follows when you go to the site.com. They now see pretty much everything they saw before except where you're coming from. You've hidden your IP address by bouncing it through those 3 servers in the Tor network. Does that make sense? Okay, cool. Oh wait, was I on that? Yeah, so at site.com, they have that. So now Tor has solved all of these things that we listed, right? Which is super cool. Okay, now we're gonna get to the, as a web developer, how many people are in the web course? Okay, cool. So as a web, how many are in like the first, it's trimesters, right? First trimester, second trimester, third trimester, just, okay. So a lot of firsts, so I'll try not to rush through too many things. I think we have time until they take the little shepherd's hook and yank me off here. So since Tor goes through 3 hops, when you're writing code that you want to be accessible on the dark web or through a Tor browser, you have to optimize for latency. So have any of the web, have they talked about performance, like optimizing performance in website? Okay, so I'm gonna punch a hole in maybe one of the common things, which is there is a much bigger difference in getting a faster page load if you optimize for latency versus bandwidth. So I don't know if anyone's made that distinction in any of the classes yet. Okay. So let's talk about why that is. So I used to work on the site called MDN. Anyone use MDN while you're doing your? Yeah. Okay. So I helped start that Python wiki at Mozilla, and don't work on it anymore, but still lots of love for it. So if you are on Mozilla Developer Network, you go down into your developer tools and look at the network tool, you'll see how much time it took to sort of get the MDN page to your machine. And so that really big box that is like 99% of it, all of that is the latency. And then that little tiny piece over there is the bandwidth. So don't optimize that part, right? So some numbers, if you go to MDN on Firefox and it's cached, it takes half a second. If it's uncached, it takes 1.4. But if you go to MDN on Tor, cache takes 4 seconds and uncached takes 12. So it starts to get quite a bit slower. MDN's a pretty good optimized site. It's probably a lot faster by now too. Let's go to like Wikipedia, the article on North Korea. And if you were trying to go to the uncensored, unblocked version of the Wikipedia article on North Korea using Tor, which you might want to do, the cached version takes 4.5 seconds and the uncached takes 5 seconds on Firefox. If you do it on Tor, it takes 82 seconds on cache, and it takes 92 seconds on uncached. So Wikipedia loads, and the reason is Wikipedia makes lots and lots and lots of HTTP requests in its content. So the number of HTTP requests that you make inside of a page is going to be the killer on your page performance. So there was, well, we'll not get into that because it was a was, and if y'all are just learning now, then just forget it. Pass is over, y'all. 2024, marching ahead. Okay, so reduce the number of HTTP requests. So minimize the number of requests in your pages is the number one thing that you can do to improve performance on web pages. Like from just, that's how you do it. So y'all talk about asset bundling, like where you minify images or you minify JavaScript, you can create bundles. Okay, so that means that what you should do is they used to, the tools used to basically make a new bundle for every single page in your entire site. And now it's all single page applications, not as applicable, but whatever, we're gonna go with it. That used to be the wisdom, was to do that. But it's really more important to just take like all of the assets that your entire website might have and turn it into ideally 6 bundles of 6 files, and that's it. So take all of the CSS for your entire site, smash it down and serve it once on the first page load, and then the client does not have to go back and get a special CSS bundle for page number 2 or page number 3. Like those are the requests that are killing the page performance, especially on Tor. Another technique is make CSS sprites for images. You all talk about CSS sprites for images in your stuff? Okay, cool. So it looks like some of the third trimester people are going like this, and some of the first trimester people are like, no. So what this means is that you have a single image called flags.png, and then you create like some CSS styles that says, okay, there's a flags Canada, and that uses the same image, but the background position needs to be in a different spot, right? So you take this, you're taking, oh, here, just have one image with 3 different flags on it, but in this part of the page, move the image here, and this part of the page use this part of the image, and this part of the page use a different part of the image. So that's a way, instead of having 3 different flag images on a page, you have one image with all the flags, and then you use CSS to position it to show the one you want in the right spot. There's also data URIs. Has anyone touching data URIs? So this is basically, especially for small images, you can just base64 encode them and put them straight into the CSS. So now it's not even another image file that has to be loaded at all. You can just stick it right in the CSS. Can you all see that? Okay, yeah. So yeah, in this case, that's, oh, there, it's zoomed in a little bit. See, I prepped myself. So yeah, with that CSS up there, you can see that the background just has URL, data, and then here's the base64 encoded, blob of that image. And then inside of HTML, you stick it in there and it's like, hey, that's an image now. And you didn't have to make another request. Images are in the CSS. We're also getting a little sort of in the weeds, probably over optimizing. Icon fonts are things you can use for icons instead of having lots of icons. Probably easier to just put all your icons in like a CSS sprite because icon fonts can be hard to work with. Let's see, what's that icon font? Let's not worry too much about that. Browser resource hints, these are pretty cool. That they probably don't get covered a lot, but if you are linking in like a style sheet, you can actually put the preload on it if you know that it's going to be included. So the way that a browser brings in a page, if it has this LinkedIn style sheet, it won't actually go fetch that until it encounters a style that's in it. Or how I did know that. Anyway, let me see if, all right, I've forgotten how to, go look at this MDN article on preloading content, and it'll, I've forgotten this one. But there is one called prefetch, and this is if you're on page 1 of a site, but you know that it's highly likely that someone's going to go to another page, and there's a resource on there that will need to be loaded when they hit that page. What you can do is you can actually put that resource in the first page and say prefetch. The browser will actually wait until it's idle with the first page, and when it hits idleness on the first page, it'll go start prefetching things that it might need in the future. So while people are reading your first page, it can prefetch things that are going to come in future pages, so when they click that, it's going to be much faster. Pre-connect is a similar thing for basically making the DNS requests. So if somebody is likely to navigate to another domain off of your page and you want the DNS fetch to happen first so that when they click on that, it'll go faster, you can do a pre-connect on that. And then CDNs. So do they talk about CDNs in the web stack? So content delivery networks, or just like, I'm trying to think, Fastly or Cloudflare, that kind of stuff. What is Amazon's called? CloudFront, I think, or something like that. So what they do is essentially they try to, when you serve your static assets like images, that you can put an entire network, a content delivery network that has servers that are much closer to maybe where your visitors are. And so the first time somebody comes from a long way away, the content delivery network will cache it geographically much closer to that location so that the next person who comes, it doesn't have to go all the way to your server, it just gets it from the content delivery network, so it's a lot faster. So Cloudflare is a very popular one of these. So you can use CDNs, that helps a lot. So now, yay, your site is faster for these Tor users. Remember we were talking about Tor. I promise we'll get there. But your Tor users are now going to get hacked. So remember these 3 new Tor relays that are in between the Alice and the site and site.com that Alice is trying to get to? Okay, so Alice has gone and fetched the 3 IP addresses and public keys of the relay servers that she's going to use. And remember, the public key is sitting there in the listing. And I have a whole other talk on cryptography, which y'all saw some of it. I have another part of it or piece of it that goes through the math, which is super cool. But the main point that's necessary for what we're talking about here is that Whitfield Diffie and Martin Hellman came up with an asymmetric cryptography protocol so that 2 people who have never met in any shape or form at all can establish a private secure channel using shared public keys, which is why you can do things like, hey, I have a cryptography key, but this key is allowed to be public, so I can just publish it to anybody and everybody, right? And we can use that in order to establish a new shared secret between you and I. And I can establish a different shared secret between you and I and you and I and you and I. We all have our own, but it's all based on my public key. So that's what you kind of need to know about that. So in Tor, what that means is that Alice looks up the IP addresses and the public keys of 3 Tor relays, and then she first encrypts her data with the key of the last one, or the exit relay, and then encrypts that with the key of the middle relay, and then encrypts all of that again with the key of the first, or what's called the guard relay. When Alice sends this sort of triple encrypted data to the first relay, it can't see any of the original data. It can only decrypt the outer wrapper to see the IP address of the next relay that it needs to send the data. That's all that it can see. Then the middle relay can't see the original data. It can only decrypt that middle layer to see the IP address of the next server that it needs to send traffic to. And then finally, the exit relay can decrypt the innermost wrapper and see the original data. Does that make sense? Okay. So usually when you hear people say this is triple encrypted, it's meaningless garbage. Like there's like a good encryption scheme is, you know, mathematically unbreakable, which see cryptography talk for all of that. But like there's no point in triple encrypting something if it's just encrypting at rest or something. But this triple encryption has this very specific purpose, right? So the triple encryption we're talking about here is designed this way for a very specific reason. Okay, but this also means that now the exit relay can see all of the original data. So now we've kind of moved that hacker in the middle from being on our local Wi-Fi to being this exit relay, right? So now this person can hack all that traffic, and then anywhere down along the line, that can also get hacked. So the exit nodes are now the sort of man-in-the-middle threats that we're used to for the local Wi-Fi person. Anyone watch Mr. Robot? Okay, so Mr. Robot, no spoilers. This is the very first episode, the very first intro before the title pops up. Elliot Alderson is confronting someone who's running like a child pornography ring on the dark web. And so basically Elliot has hacked into this person's, you know, dark web service or whatever, and says the onion routing protocol is not as anonymous as you think it is. Whoever controls the exit node is the one who controls the traffic, which makes me the one in control, and this is exactly what he's talking about. So in that show, which is very accurate, by the way, Mr. Robot is extremely accurate, and the tech consultant on that writes a bunch of really good privacy and security books. So his name is Michael Bazell. And I got to talk to him, yeah. So what you really need is you need Tor and HTTPS to protect location, destination, user password, data, all of that stuff. So for the rest of our code, you should use HTTPS, and oh my gosh, you should be doing this anyway. I promise, coming soon, there's an HTTPS talk that's based on this book called The Early History of Data Networks, kind of like the cryptography one. It goes from ancient times to modern times. The most applicable thing is, who's heard of Let's Encrypt? So Let's Encrypt is a super cool nonprofit out there that automates and makes free HTTPS certificates for anybody and everybody. So if you're using like a hosting platform these days that, you know, you just publish your single page app to it, or, you know, Fastly, all these other ones that'll serve that, they're all powered by Let's Encrypt, because Let's Encrypt can give free HTTPS certificates out to anybody and everybody. If you were to do it yourself, I've got instructions for, like, you can install certbot, and then you would say, here's the domain I want to get a certificate for, and it will say, cool, you need to go deploy this value out on your DNS to prove to us that you actually own that domain. And then once you do that, you click a button and it says, cool, here's your certificate, and then you put it on your web server, and now you've got HTTPS. So in the in your careers, since if you all are just getting started in your careers, I never want to hear of any of you publishing anything over HTTP at all, ever. There's no reason in this day and age. Everything should be HTTPS. I got another talk. This is turning into a lot of plugs for a lot of my talks. Another talk, we can talk about web security errors that we see from Firefox and how HTTPS fixes it. Another talk on observatory.mozilla.org, which is a fantastic site for when you're using HTTPS, go point this scanner at it and it'll tell you how you could be using it better and better. And then the web security section on MDN is really good for this. But back to our diagram. So if you're using Tor and HTTPS, now we've fixed that problem. So Tor is protecting the location, and HTTPS is protecting the user password and the data. So yeah, your code is faster and more secure for Tor users, but oh noes, your code is broken in Tor. So remember we said Tor is a patched version of Firefox. It's actually the patched version of what's called the Firefox ESR, or Extended Support Release. So if you go to inside Tor and do About Tor, it'll tell you that it's based on Mozilla Firefox, this version. We publish a new Firefox release every like 2 weeks, but it was like every 4 weeks. That's not good for Tor because they maintain a bunch of patches. And so if we start changing stuff every 2 weeks on them, their job gets really hard. So what they do is we also have this extended support release where we pick one of our versions and we don't make any more changes to it except for critical security fixes. And that's what we call our extended support release. And we leave that one in its state for more like a year. And so Tor builds their browser on top of our extended support release so that they don't have to keep patching all the time. So that means if you want to make your code work on the dark web, you got to make it work in Firefox ESR. So to make your code, you should also just make your code work in all browsers. I know the browser wars are dead again, and then they come back, and then now it's dead again. Everyone's using Chrome, but it is important that there are multiple browsers out there. This doesn't have to be a Mozilla rant. So just download Firefox ESR. Firefox DevTools are really good to see like, hey, what's working in Firefox ESR? There's a site called caniuse.com, which tells you which browser versions support which things might be in your code. So you can compare between different browsers and say, oh, this browser version supports these, this one supports these, that kind of thing. MDN, another good resource for like browser compat. Kangax.com is basically can I use for JavaScript. There's a bunch of coding tools these days that basically, if you're using stuff like this, like auto prefixer or any of this, it's probably doing a lot of this for you. So hopefully now the tooling has gotten where you don't have to worry too much about browser compatibility. Okay, so your code's working for Firefox ESR, but might still be broken in Tor. So remember, Tor is a patched version of Firefox, not just Firefox. So if you go to Tor browser, they have a design document that you can read. It's really, really dry. It's really, really boring. But they base a lot of their work on what's called adversary models, where they talk about what's the goal of a certain adversary, what's their capabilities, and these guide what Tor does in their patches. So let's do an example. So over here, we have an example of, in this case, like law enforcement might confiscate somebody's computer, right? And then find a bunch of information on it. So Tor has that adversary model in mind, and what they do is they have this thing called disk avoidance. So they have a patch that basically tells Firefox, don't store anything on the disk, ever. So we don't touch the disk when we're running Tor, so that if somebody were to grab your laptop, they have to get a memory snapshot out of it in order to see where you were, what you were doing, any of that stuff, right? But that means for a web app, Tor users will have to sign in every single time. There's no going back to a site through Tor. Like, it doesn't store any cookies. It doesn't store any of that stuff. So a Tor user is going to have to sign in every single time. Another example would be if someone's running a hidden service that's actually trying to identify people, what they'll do is they'll try to fingerprint the browser or the device that is visiting this hidden service. So maybe this hidden service is more like a honeypot or a trap. So they want to fingerprint that device and capture a fingerprint of it, and then go find, if they see that fingerprint out on the clear web, then they might know, okay, this IP address connected with this device fingerprint. So we know that this person is the one who is visiting this hidden service. I've got a whole other talk on fingerprinting. Don't worry about it. But what Tor tries to do to address this is this really fancy word that just means they try to make all of the Tor browsers look exactly the same, no matter what screen size you have, no matter what operating system you're running on. They try to make them all look like they are a Windows 7 machine with, in the UTC time zone, like all of them try to look identical so that you can't fingerprint based on these parts of the device. So because of all these patches, if you really wanted to debug your code for the dark web, you go download Tor. Because Tor is Firefox, it comes with its own dev tools, the Tor dev tools, which are just the Firefox dev tools. Some of your code might still be broken because Tor has this sort of security slider where they can, if you're doing very sensitive stuff, you can slide it all the way up to high, which means they do even more things, like they disable all JavaScript, they disable SVG, there's no web fonts, because all of these things are basically vectors that could identify somebody, so they disable everything. No JavaScript. Wait, we're web developers. How the heck do we live without JavaScript? So the reason they do that is, very specifically, there was an instance where like a site had been compromised and taken over by law enforcement, and then they actually found a like 0-day in JavaScript, in the JavaScript engine of Firefox, and they put basically targeting this specific version of Firefox, which was the Tor version of Firefox, into a payload that, when executed, would basically make an out-of-channel communication to another server, so that even though you went to a hidden service like a dark web site, they could make Firefox make a clear web connection at the same time that you went, so they could see your IP address as soon as you landed on that. So they exploited a JavaScript 0-day in order to do that, which is why at the highest security slider, it just disables JavaScript. Okay, so summary here. optimize for latency, make it work in Firefox, and then make it sort of, I guess, I forget what do they call this now. It used to be called graceful degradation. Now it's called progressive enhancement of web apps, where like, even if somebody has all of these things disabled, your app should still work, and then it should get better if they have, fancy bells and whistles turned on. So your code works, it's fast, and it's more secure for Tor users, but now you are going to get owned if you were trying to stay anonymous. And now we're finally at what you would call the dark web. So a way to think about it is you got the surface web. This is basically the part of the web that can be crawled by a crawler, right? So it's just out there, it's public. Then you have the deep web, and this is what you would say is the things that are hidden behind some kind of layer of access control. So this could be as simple as you have to be signed into Twitter to see a bunch of people's tweets, or you have to be, on you have to be signed into Wikipedia to see a certain history or something like that, right? So that's what they call the deep web. And then the dark web is basically like, okay, you have to be on the Tor browser in order to reach this, right? Another way that I saw it, which was kind of humorous, was at the top you can turn a computer on, and in the middle you must be really bored, and at the bottom, use a proxy or say hi to the FBI. Okay, so back to this diagram now. If you're the one trying to stay anonymous, you're no longer this person up in the top left. Now you're the person in the bottom right trying to run site.com anonymously. So how do you usually set up site.com? You go to a registrar and you register. Well, so first your computer has an IP address, but you need a domain name in order to run site.com. So DNS is the solution to that. Have you all talked about DNS yet? A little bit? Okay. So DNS is basically, the big analogy is it's like a big phone book that says, site.com is actually over at this IP address. But to get those domain names, you have to use a registrar, and then there's all these entities that you're basically, exposing yourself to. So when you go sign up, you have to use a sign up form. This is not anonymous, right? Your payment credit card for the domain name is not anonymous. So how do you actually set up site.com anonymously? For our purposes, instead of setting up site.com, you actually set up site.onion. So a .onion is a Tor hidden service. So they call them a Tor hidden service, not a clear web website. And a Tor hidden service uses what's called a rendezvous protocol rather than DNS. And the way this works, try not to race through it too much, but so in this case, now we have Bob is running a server, and Bob wants to stay anonymous. So Bob is running Tor, and Bob's Tor client picks 3 introduction points out on the Tor network and says, this is where I'm going to get introduced to clients that want to reach me. Bob advertises the hidden service xyz.onion at a central database, or there's like the directory server listing, but it's a separate one. So then Alice hears that this xyz.onion exists, and so she requests more info from the hidden service database, and she also sets up a rendezvous point. So there's an introduction point that Bob picks, and there's a rendezvous point that Alice picks. They both build like that 3-hop circuit to these things, so that the rendezvous point and the introduction point don't know either of them. If you want to know like where you go find Tor hidden services, like you can just go to r/onions and start poking around, right? Like they're a little hard to find, but it's not impossible. So now Alice writes a message to Bob that's encrypted with Bob's public key, which she was able to get from the database. And she puts a one-time secret in there. So it's just a secret value she's going to generate to say, hey, when you come back to me, I'm going to know you're Bob because you have the secret that I'm giving to you. And so she asks one of those introduction points to deliver that to Bob. And once Bob gets that, Bob connects to, she tells the introduction point, here's where I want Bob to meet me, over at this rendezvous point. So then that is sent to Bob. Now Bob can decrypt that with his public key, or with his private key, and then says, oh, okay, Alice wants to meet me over at this rendezvous point, and here's the one-time secret that she sent, so that whenever I get there, I can prove to her that I'm Bob. So connects to the rendezvous point and gives it the one-time secret, and Alice confirms, yes, this is the right one-time secret, and now they've established a connection point between the two of them that is completely anonymous. So this diagram now has 3 more Tor relay nodes in the middle of it, right? So now you've got the 3 up there and the 3 down there. So now there's 6 hops going on. Okay, the good news is doing that is way better than talking about it. It's actually faster to do that than it was to talk about it. So if you are running a web server and you want to run it on the dark web, you just download Tor, and then you edit your Tor RC like config file, and then you run Tor. So let's say I'm running this web server is the conference static page of where I was giving this talk first. I go into my Tor RC file and I just say, hey, there's a web server running on 127.0.0.1. Like I want that to be on the dark web. And then you fire up Tor and it does everything I just said automatically. And now it gives you at the end of it your onion name. So you've got this. Here's the onion that your site is now accessible at, and then you go in the Tor browser and you can see now you're on the dark web. So it's way easier to say than it is to, or way easier to do than it is to explain. And if you go in the Tor browser now as the client, what you'll see is the first 3 connection points that you're using, but you don't know the connection points that the hidden service is using. So you don't know who they are, they don't know who you are. So, yeah, your onion is working, but since it's going through 6 hops now instead of 3, you really, really, really need to optimize for latency if you're running a hidden service. So that's just a review of what that was. We'll skip the question of CDNs on Tor. But yeah, optimize for latency. If you're running this hidden service, you might still be hacked or identified. There's a tool called Onion Scan, which is like an anonymity scanner for Tor hidden services, which is maybe the nerdiest thing I've ever said in my life. But what it'll do is you point it at a hidden service and it will go and find things like email addresses, right? So an email address anywhere in your site might be identifying somebody. So if you want to run a hidden service, you want to stay anonymous, you got to do something like get an anonymous email address. There's a bunch of providers out there, Proton Mail, Tutanota are great ones. They also have their own hidden services to access your webmail through Tor so that they don't know who you are when you're using their mail services. We also have relay.firefox.com, which is what I work on a lot. But you can get, so now you have this anonymous email. You could still get hacked or identified. So one of the other things that Onion Scan found on this was there was an image on our website that was sort of the venue, and inside of this image is EXIF metadata. So who's heard about, EXIF metadata? Who's seen me give a hacker story about EXIF metadata? Okay, well, it's a teaser. But inside of there, you might see when a camera takes a photo, it can include the location data down here, so the latitude and longitude of where it was taken. And if you put that on a map, you can see that that was in downtown Tulsa because it was at the Tulsa Library, right? So this information would be useful to investigators who might get hold of this file. So for example, I have another talk where I show how I use the EXIF metadata from image uploads to the alt-right website Parler to identify all of the Parler users who took pictures in the US Capitol grounds on January 6, 2020. So that's a good hacker story. We'll do that one sometime. Come to a Techlahoma event, you can hear all about that one. So if you're trying to run a hidden service and you want all of your users to be anonymous, you need to strip out that EXIF data from anything that people upload, right? Or they could be identified. So you get location-free images, but people still might get hacked or identified. So this other image basically had somebody's name in it. It was like CaitlinStewart.jpg. Like, oh, well, that's not good. So if you're trying to run a hidden service and you want your users to stay anonymous, you need to like basically mangle the file names. So they're like, and you probably see this now most days when you go download a file or an image from a website, it's usually like just J465, it's just like some made up name. Well, they're doing that because file names can contain lots of personal information. And then Onion Scan has lots more checks. Okay, oh, here's a fun, I don't know, has anyone heard the hacking Nazis on the dark web story? Okay, well, you're about to hear it. Okay, so some attacks are maybe not easier, but different on the dark web. So we're going to do a phishing attack. So phishing on the clear web, familiar with phishing, basically. Okay, so phishing relies on, you go register a site like Amazon with 2ns.com, and then you put an Amazon login form on your site, and then you go try and like trick people into going to your site rather than, you know, the real site, and you get them to punch in their username and password, and now you've got it, okay? So phishing on the dark web is a little different because, like we said, you don't use DNS, you use this rendezvous protocol, right? And you get these random .onion names. But there is a Rotten Onions attack, and the first one that I heard about that I thought was super cool was just somebody goes by the name of Crime Wave, would basically go and spin up a bunch of hidden services that had onion names that looked like real online darknet markets, and then basically like looked like a real store, all this stuff, and then started putting their sort of trap onion names out on all of these wikis and places where people were looking to buy drugs or whatever online. So when people got there, they would basically get them to give them their username and password for a real darknet market, and then they would harvest all of their usernames and passwords, they sign into the real darknet market, and then drain their entire like cryptocurrency account out of that, right? So when the way you do this is, yeah, so now our diagram is crazy, right? So if I'm going to do this, which I am, I'm the hacker, and so I'm going to brute force a bunch of .onion keys. So those names are random, but if you just generate a ton of keys, then eventually you'll get a random domain, or you'll get a random name that looks enough like a real one that someone who only glances up at the address bar in Tor will probably be tricked by it, right? So same as regular phishing. What that means is that in this case, you've got the entire Tor hidden service circuit going to my hidden service. I'm in the middle, and then I'm going to mess with that traffic and then use Tor hidden service to the real like dark web site that I'm hacking. Does that make sense? So I'm putting myself in between this end user and that person who's running a site that I don't like. So you remember Charlottesville, Unite the Right rally, all that kind of stuff. A lot of my hacktivism projects, they're based on popular news stories, which end up being political. I'm not actually a very political person, but like when stuff happens in the news, that I'm like, I wonder if I could hack my way into that. Oh, right. So I'm going down to Dallas to watch the USA soccer team play Jamaica right after here. I'm leaving to go do that. So that's why I have to be decked out in all my USA soccer gear. So anyway, there was a site called the Daily Stormer that was one of these, alt-right neo-Nazi websites, and they had helped organize the Unite the Right rally. And so whenever that went as horribly as is totally predictable that it could go, like Google and Amazon and other of their sort of internet providers were kicking them off of the clear web. They're like, we're not hosting your site, we're not protecting it from DOS attacks, whatever. So they pulled all their protections from it. Bunch of online hackers went and DDoSed the site over and over and over again until they finally just left the clear web, and so they go to the dark web. So I'd been poking around with Tor a lot when I heard this news, and I was like, that's interesting. I wonder what you can do with them. So they have this, their site is I can't read it. So what they did is they generated a ton of keys till they got a hidden service name that was like DStormer and then a bunch of, garbage after that. And I went to their site and I noticed that they had this Bitcoin address that was like collecting donations to keep the site online and all that kind of stuff. So I thought, okay, cool. If I want to stand up a bunch of alternative, like everyone's looking for them on the dark web. So if I go generate a bunch of DStormer something.onion sites and start putting them on all the wikis and the Reddit forums and all that kind of stuff, then I can probably get a bunch of them to go to my sites instead, because everyone's looking for where's the new DStormer, right? So there's this tool called Scallion, which you can use, that uses your GPU to create a ton of these keys. So you can create 115 million keys per second. So It took, for each onion that I wanted to find that started with DStormer, it took about 1 hour and 41 minutes for it to find one, right? And it would go through, what is that, that's 701 trillion hashes. So I just let the thing go on the GPU, and 2 hours later I come back and it's created another DStormer address, right? So then I run my own hidden service at that address, and all it is a man-in-the-middle proxy server. So it's a web server, but the whole point of this is to say, I want the traffic to come to me, I want to be able to do stuff with it, and then I want to go get content from some other place and then send that back, and then I can mess with that traffic too, and then I send it on, right? So I didn't have to set up my own content, I didn't have to make a fake site, I didn't have to do any of that, I'm just proxying traffic on the dark web. But with this script, this replace btc.py script, what I can do is I can say, okay, when you're sending that page back, instead of this Bitcoin address, which is theirs, I want you to replace that with this Bitcoin address. So if you go to my site and you try to donate to DStormer, you're actually going to donate to tunapanda.org, which teaches tech skills to low-income people in Africa. So Nazis are hacked. Yay. So this gets to the point of writing code for the dark web can be really fun. Like when I was first getting on the internet, it was also first kind of like starting, and it had this really explore it. You could just go explore it, right? Like now I kind of feel bad for y'all because it's been so commercialized and there's so many libraries, there's so much stuff you have to learn. Like in the early days, there were like 3 or 4 technologies you had to learn, and then you could just go nuts, right? And so it was fun to just kind of like explore and tinker and, oh, I broke that or whatever. Oh, I found NASA's FTP server. Oh, I don't know what I could download. But it also makes your code better. So like think about all the performance things we talked about and the security things we talked about just by, hey, if I were to run my code on the dark web, it makes you think a lot about those kinds of things that you don't normally think about, right? So it makes your code faster, more secure, more compatible, and it makes you think about your privacy, and it makes you think about other people's privacy. This is I haven't updated this. There's been a lot of dark web. So when I first gave this talk, it was one of the common things said about the dark web is like, that's the place where you go buy drugs, right? And I used to make the joke like, well, if you're like 70% of America, you probably already agree that marijuana should be legal, and now it is, right? So it's like, oh, whoa, this talk is, because I did some sort of research on the darknet markets that are out there. And so let's go for, what was the chuckle? Yeah. So like just on one of the darknet markets that I found, 63% of the stuff for sale was like marijuana, right? And now that's legal. So we were using the dark web to do something that is basically like, hey, this, and there's a whole other Bruce Schneier talk about that. But most of the sites on the dark web are not actually illegal. And so there's been some cool research done. OnionScan report, so the gal who maintains the OnionScan tool has scanned the dark web kind of like once per year and does a report on what's on it. I haven't updated these, but more than half of what they found was just plain sites that are just on the dark web also. So the dark web is kind of neutral tech, it's anonymity tech. And clear websites also use the dark web. So Facebook runs a hidden service because they need to evade censorship in some countries that censor Facebook. Proton Mail does that. There's like search engines, and then a really cool one called Secure Drop, which is actually a dark web hidden service like CMS for whistleblowers to basically go and drop off a bunch of the evidence that they're finding, and they can put it in there. It's set up by the Freedom of the Press Foundation, and these are the number of journalistic outfits that have a secure drop service out on the dark web, right? So people can go there. And the way it works is like if you go to the Guardians, you can submit documents for the first time. And if you do that, the only thing you ever get is this really long random identifier. That's the only thing that you have to write that down, and then you can keep communicating with the journalist that you're sharing files with. So it has all this complicated setup, blah, 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 blah. We're not going to talk about any of that, and that was all a joke anyway. Okay, so you're probably not going to be building Secure Drop whenever you all are out there, in the world. But you can respect your users' privacy who are using your websites or your web apps. So if you want to look up, there's a cool like body of thought called Privacy by Design. So especially if you're into like the design side of things, there's like a school of privacy by design. Privacy guidelines for designing personalization, because there's been too much of this sort of like, there's a conflict between how you can personalize your applications for people. That means you need a bunch of their data. You don't. So there's ways to get around that. And then when we talk about privacy in general, like one of the times I gave this talk, one of my friends, Trisha, from when I was giving this at Thunderplanes, said, I've always wanted to try Tor, but I heard it puts you on some kind of list, and I plan to travel soon, right? Which touches on a privacy preachy part, but so Glenn Greenwald, who, if you look him up now, he's a little off the rails, but at the time he was a little less off. He was a little on the rails. He's the one that worked with Edward Snowden to sort of publicize what Edward Snowden had found about the NSA's spying on all of our, internet traffic and that kind of stuff. And so he had a TED Talk, and he said there's dozens of studies that show that when somebody knows they're being watched, the behavior that they engage in is vastly more conformist and compliant than when they know that they're not being watched or they think they're not being watched. So we'll skip all of that. So basically there was a sociologist named Jeremy Bentham who realized that this could be used in designing a place like a prison. So Michel Foucault is really into prisons. So basically, if you could design a prison where in the middle of the prison there's a tall tower, and so the inmates cannot see into the tower, but they know that at any given time somebody in the tower could be looking at them. This is how you could basically control an entire population, not with actually going in there and, jailing them or putting them in isolation or anything like that, but just make them feel like they're being watched all the time. Because if they assume they're being watched at any given moment, then they basically are carrying their prison around inside their mind all the time, which is kind of a disturbing thought. Yeah, but this is like people understood this psychology, that people who are watched basically behave very differently, and you could exploit that to control people without having to rely on sort of like the normal tools of oppression, like put people in jail and all that other kind of stuff. And then Bruce Schneier also has a book called Dating Goliath. And he talks about how there's a strong physiological basis for privacy that we all want. So there's a biologist that said the desire for privacy is innate. Mammals in particular don't respond well to surveillance because in the wild, animals in the natural world are watched by predators. So when we are watched by predators, it makes us feel like prey, and it actually makes people who watch us act like predators. So that's kind of the preachy part. There's a really cool book called Obfuscation. Let's see how much of this other stuff. Oh, so the spoiler alert is, so I've done a lot of weird things on the internet on Tor, as I told one of the stories, and I've never had trouble traveling. So I encourage you all to go download Tor, check it out, poke around on the dark web, and then I guess I'll just do questions now. Okay, so you find them in the same place.